A winter cup starts with powder engineered to dissolve, disperse, and taste consistent every time. Every packet depends on precise dry blending long before hot water or milk touches it. The real transformation happens when very different powders become one uniform, free-flowing mix. The factory's goal is simple: turn complex ingredients into one dependable everyday cup. Hot chocolate feels simple at home because the difficult measuring and mixing happened earlier at the factory. The same dry mix also helps cafes serve consistent drinks quickly during busy periods. Bulk mixes can simplify service when many cups need the same flavor and strength. One drink links tropical agriculture, dairy engineering, sugar processing, powder science, packaging, and daily routines. Powder factories manage tiny differences because color, flavor, flow, and dissolving behavior all affect the final cup. Sensors track the process continuously, while people decide whether the data still represents good product. Powder production looks clean and quiet, but reliable dust control and maintenance are essential behind the scenes. We will follow each major ingredient, then see how the factory turns them into one instant drink mix. Cocoa begins far from the American mixing plant, in warm regions where cacao trees can grow. Harvesting selects mature pods because bean development affects flavor long before industrial processing begins. Fresh cocoa beans do not yet taste like cocoa powder. Fermentation begins the flavor transformation. Fermentation changes bean chemistry and helps create flavor precursors later developed during roasting. Drying lowers moisture so beans can be stored and transported without continuing uncontrolled biological activity. Even drying reduces pockets of wet beans that could damage quality during storage and shipment. Once dried, cocoa becomes a stable traded ingredient ready for long-distance transport. Industrial cocoa processing begins by turning agricultural variation into a controlled raw material stream. Cleaning protects roasting equipment and removes material that should never enter the cocoa process. Machine vision adds speed to sorting, while quality teams monitor the pattern of rejected beans.
Roasting develops chocolate aroma while reducing moisture and preparing shells for easier separation.
Cooling stops roasting from continuing and stabilizes beans before cracking and winnowing. Cracking opens the bean so the valuable nib can be separated from its lighter shell. Air separation works because shells and nibs respond differently to the same moving air. Grinding releases cocoa butter inside the nib, turning solid particles into a flowing cocoa mass. Cocoa liquor contains cocoa solids and cocoa butter, so it behaves very differently from dry powder. Pressing separates much of the cocoa butter from a dense, solid cake rich in cocoa solids. One cocoa stream becomes valuable butter, while the pressed cake becomes the starting point for powder. Cake must be reduced carefully because hot grinding can affect flow and powder handling. Grinding turns press cake into the familiar powder that carries cocoa flavor into hot chocolate mix. Particle size control helps cocoa blend more evenly with sugar and dairy powders later. Conditioning helps control how cocoa powder behaves during storage, transport, and later blending. Small differences in cocoa color or particle size can become obvious once the final drink is mixed. The cocoa ingredient is ready, but the final product still needs dairy, sugar, and powder engineering. Milk powder begins as liquid milk that must be cooled and protected before concentration and drying. Temperature-controlled transport preserves the raw milk until the processing plant can verify and accept it. Sampling gives the plant evidence about the incoming milk before it joins a larger production stream. Early processing creates a cleaner, more predictable liquid feed for concentration and drying. Thermal treatment supports safety and prepares the milk for the next concentration stages. Evaporation reduces the water load before spray drying, making the final drying step more efficient. Homogenization can stabilize dairy concentrates, so fat and solids behave more uniformly during drying and reconstitution. Spray drying creates powder by exposing small droplets to controlled hot air for very rapid moisture removal. Powder recovery systems capture fine particles that would otherwise leave with the dryer exhaust. Multi-stage drying can improve powder stability, flow, and the way particles later dissolve in a drink.
Sifting keeps the ingredient within the particle range expected by the hot chocolate blending system.
Powder quality is not just flavor. Moisture and flow determine how reliably factories can dose it. Low-moisture dairy powder needs protection from humidity because water pickup quickly changes handling behavior. The dairy ingredient now travels as a lightweight, shelf-stable powder instead of refrigerated liquid milk. At this factory, milk powder becomes one part of a much larger dry blending recipe. Keeping powders identified and separated prevents the wrong ingredient from entering the wrong recipe.
American sugar begins with beets, showing how a root crop can become a crystalline food ingredient.
Slicing exposes more surface area, so hot water extraction can remove dissolved sugar efficiently. The refinery removes plant solids and impurities before concentrating the dissolved sugar. Concentration removes water until the sugar solution is ready for controlled crystallization. Centrifugal force separates crystalline sugar from liquid syrup without changing the crystals themselves.
Drying and cooling help sugar remain free-flowing during storage and later high-speed dosing.
Finer sugar can disperse more evenly with cocoa and dairy powder in a dry beverage blend.
Minor ingredients weigh little, but small dosing errors can noticeably change the final cup.
Some instant mixes use surface-active ingredients or agglomeration to help dry powder wet more easily. Dry powder production begins by controlling moisture before the powders ever enter a blender. Ingredient control begins with confirming that the correct material arrived in acceptable condition. Sampling lets quality staff test a large delivery without opening every container. A powder that flows poorly can cause feeding problems even when its flavor is perfectly acceptable. Sugar particle size affects how evenly it distributes through the finished hot chocolate mix. Cocoa is naturally variable, so factories use specifications to keep the final drink visually consistent. Ambient humidity matters because several recipe powders can absorb moisture from the surrounding air. The right response is to control the environment and verify material condition before restarting normal handling. Production continues only after evidence shows the humidity event did not damage ingredient performance. Dedicated hoppers reduce manual handling and make each recipe component easier to meter accurately. With ingredients released, the factory can focus on the hardest problem, achieving uniformity in every scoop. Automatic feeding replaces guesswork with measured mass flow for every ingredient entering the recipe. Closed transfer controls cocoa dust while keeping the ingredient moving predictably toward the blender. The balance between cocoa, dairy, and sugar determines body, sweetness, color, and overall drink character. All ingredients are often pre-blended, so they spread evenly instead of forming concentrated pockets.
Pre-blending turns tiny doses into a larger carrier stream that is easier to distribute uniformly.
The blender's job is not to create new chemistry. It must distribute particles evenly throughout the batch. Mixing creates repeated particle movement, so cocoa and dairy do not remain in separate zones. Mixing too briefly risks uneven flavor, while unnecessary mixing wastes time and can change particle handling. Dust control improves housekeeping, protects workers, and reduces powder escaping from the intended process. A finished batch is not assumed uniform simply because the blender timer reached 0. Multiple sample points help review whether cocoa and other ingredients distributed consistently through the blender. Color is a fast, practical indicator because uneven cocoa distribution can make different servings look noticeably different. Reconstitution testing connects dry powder measurements to the way customers actually experience the product. Clumping can appear even when the recipe is correct if powder particles do not wet and disperse easily. Investigation asks whether the problem comes from ingredients, mixing, or the way particles interact with liquid.
When composition is correct, particle engineering can improve how the powder behaves during reconstitution.
Agglomeration can turn very fine particles into larger structures that wet more readily when liquid is added. After agglomeration, controlled drying stabilizes the new particle structure without turning it back into dust. Some instant recipes use lecithin to improve wetting, but the exact formulation varies by product. Cooling protects flow and packaging performance by avoiding warm powder entering sealed containers. Final sifting controls oversized material while preserving the particle structure created for easier reconstitution. Foreign material controls add another barrier before the powder reaches consumer packaging. A surge bin separates batch processing from continuous packaging, so both sections can operate more smoothly. Bulk density matters because package fill height and scoop behavior depend on how much space the powder occupies.
Reliable flow helps feeders and packaging machines deliver consistent amounts without bridging or sudden surges.
A factory test should imitate real use closely enough to reveal whether the product behaves as intended.
The payoff of particle engineering is visible when the dry blend becomes a smooth drink with less effort.
Batch release combines instrument data with practical drink performance before packaging begins. Powder plants manage recipe changes carefully because leftover material can affect flavor, allergens, and traceability. This is the factory's core transformation. Separate powders become one stable, convenient instant beverage mix. Single-serve packaging starts as flexible film that is shaped around a measured dose of powder. Packaging accuracy depends on keeping both powder flow and film movement synchronized.
Automatic weighing catches packs that may look normal, but do not contain the intended amount.
One rejected pack becomes evidence that helps the operator trace a small dosing problem upstream.
Powder buildup can disturb dosing, so a small cleaning step prevents repeated underweight packs.
The correction is complete only when new packs confirm that fill weight is stable again. A good seal protects dry mix from humidity and prevents powder from leaking during transport. Machine vision removes obvious packaging defects while allowing good product to continue. Cartoning turns many small servings into a convenient unit for stores, offices, and households.
The same blend can enter different package formats when dosing equipment is configured for each container. Weight control prevents large package formats from hiding dosing variation behind their size. A protected closure helps keep the low-moisture powder dry until the consumer opens it. Secondary packaging protects finished products and simplifies warehouse handling. Robots fit repetitive case handling because each package arrives in a predictable shape and orientation. Stable pallets reduce shipping damage and keep cases aligned through distribution. Finished powder still needs dry storage because packaging works best when the surrounding environment is controlled.
Obtained samples let the factory investigate later questions using material from the original production lot. Package integrity matters because humidity can change powder flow and clumping long before flavor changes. Shelf life testing asks whether packaging protects the mix under realistic environmental stress. Instrument data matters, but trained sensory evaluation still connects production choices to human experience. Low moisture helps dry mixes remain stable, but each recipe needs its own validated storage and packaging controls. Resource recovery must follow product quality rules. Not every collected powder stream should return to food. Separating clean packaging waste makes recycling easier than mixing every material into one disposal bin. Powder drying can use significant energy, so heat recovery can improve overall process efficiency. Traceability follows the product beyond the factory, so specific lots can be located when necessary. Unlike liquid dairy drinks, dry mix can travel without refrigerated distribution before it is prepared. A supply chain spanning cacao farms and dairy dryers ends as a simple product waiting on a shelf. At home, the factory's precision becomes convenience, one measured serving with almost no preparation work. Instantized particles are designed to wet more easily, helping the mix disperse with ordinary stirring. The final product is not the powder itself. It is the warm drink the powder makes possible. Following package directions helps keep flavor and sweetness closer to the product's intended balance. One winter drink connects agriculture, food engineering, powder science, logistics, and everyday comfort. The final mix is more than ingredients together. Particle size and structure change how those ingredients behave. Once you see the process, a quick drink becomes a lesson in supply chains and material engineering. Keeping dry mix sealed and dry helps protect the flow and quality the factory worked to create. The next ordinary product may hide an even more surprising chain of people, machines, and decisions.